So, hello student, this is Preeti Kshatriya from Scholars Academy. Today's chapter, which I am taking from science, is properties of natural resources. So, let's begin. This is for standard 7th. So, now natural resources. You can see the picture here. You can see the sky. You can see trees, right? Water. These are natural resources. Land, right? Air, water, and land are called natural resources. Right? Now, let's recall like which gases are present in the air. Now, we all know that there is nitrogen, there is oxygen, there's carbon dioxide, right? There are inert gases. So, this is what we are going to see here. We are going to recall that gases like nitrogen, oxygen, carbon dioxide, 6 types of inert gases, nitrogen dioxide, sulfur dioxide, extra are present in the air. Now, why is air called as homogeneous mixture? Homogeneous air is the mixture of all the gases. The constants gases cannot be separated naturally from this mixture. Therefore, it is called as homogeneous mixture. That the mixture is evenly distributed. Now, what are the various uses, of these gases which are present in the air? So, what are the uses of various gases in the air? So, as we know, nitrogen helps living thing to build the necessary protein. It is useful in the production of ammonia and in airtight packaging of foodstuff. Then there is oxygen, necessary for respiration in living thing and for combustion, that means burning. Carbon dioxide, plant use it for producing their food. So carbon dioxide is taken by the plant and oxygen is given out, we know, right? Plant gives us oxygen. So plant take in carbon dioxide for preparing their food, and carbon dioxide is also used in fire extinguisher. Then there is argon. Argon is used in an electric bulb. Helium. Helium is used for obtaining low temperature and also for generating airships, lift airships. Neon, as you can see different colors here, used in decorative lights and for street lighting. Even you can see the signages of different brands and all, they have different like Pepsi and all. They do the branding with the neon lights. Then there is krypton, used in fluorescent tubes, fluorescent lights, right? Then there is xenon. It is used in flash photography. And also you can see this, the big cars have the headlights, which is they use what you call xenon. Now here there is carbon dioxide has been used for the food production and plant and as a fire extinguisher. Oxygen, here respiration by human being, taken in oxygen, given carbon dioxide, plant take carbon dioxide and prepare oxygen and give it to us. Then nitrogen for airtight packaging of foodstuff, right? Argon, which is used as a filament with filament bulb. Helium for lifting airships. These are the neon lights. Pepsi, I told you. Krypton, flash photography, as well as xenon light for flashlights, or you can use as fluorescent tubes. Now coming to our topic, that is air. Properties of air. First of all, air. What is air? Air is all around us. Can we see air? No. By looking at this picture, we can feel that there is air. The air is blowing. So air surrounds us though we cannot see it. When we are exhaling or inhaling, the presence of air is felt. Now, this is one experiment which it is given in the textbook of yours, right? Properties of air. That air has mass and air has weight. So this can be seen by the experiment here. This is the experiment 1 of your textbook. We have to take 2 balloons, 1 ruler, okay, tie a thread in between so that the ruler is evenly distributed. It is balancing. You have to inflate the balloon. It should have the same mass. The balloon should be of the same size. Okay, we are going to hang those balloons like we have shown here, right? So when you inflate the balloon, so both the balloon you have hung, and they will be equally measuring. They will be, balanced. And slowly pierce a nail or pierce what you call your rounder or compass, what you call. So pierce that and see, slowly the air comes out, and slowly when the air comes out, now you're going to pierce it at a blue balloon. Here in the experiment, the blue balloon has been pierced and the air comes out, and you can see the balloon, the red balloon, which is blown, which is inflated already. So it weighs down, right? And the balloon, from which the air has come out, goes up. That means this experiment tells us that air has weight. The red balloon containing air atom in it has more mass than the blue balloon. Thus, it proves that air has a mass. Okay. The space occupied by the deflated balloon, blue balloon, is less than the red. Sorry. Thus, it proves that air occupies space. Now, this is about this experiment number 2 is about the atmospheric pressure. The pressure is from all over. This also can be explained with the help of balloon here. Experiment number, not balloon, with the syringe. Now, we have one syringe. It has a nozzle here. You can see it. This is the nozzle. Okay, and then there is a piston. Now you are going to pull the piston. Not going to hold anything. Only thing you are going to hold the piston and pull the syringe off, like how we fill the air, or how we feel. What we feel. The doctors fill in the injection, right? So we are going to fill the air. What will happen? The air will be sucked and the piston will come till wherever we are going to pull. But so it is easily being pulled. Now you are going to hold the nozzle tightly. You're not going to let the air move. Okay, you're just going to pull that. So what will happen? It will be very difficult for you to pull it, right? It will come out. No wonder it is going to come out. But as soon as you leave the piston will go back into its position. Now, from whichever direction you do it, from whichever direction you pull that syringe, it will go inside. From upper direction you pull it, it will go inside. From the north direction you pull, it will go inside. From the south direction you pull, it will go inside. Right? Because atmospheric pressure is in all the direction. Right? So this experiment proves, like, from whichever direction you are pulling the object, the atmospheric pressure will pull that object back. So that's after performing the 2 simple experiments given in the textbook, page number 16, we understood the following property. What we understood? That air has a mass and weight. The molecule of gases in the air are moving constantly. They are constantly moving. When molecules present in the air strike against a body, the pressure is created on that body with that piston thing. Now, the pressure exerted by air is called atmospheric pressure. See, air is moving all around. Once you pull it, if the nozzle is sealed, right? you're going to pull the air which is outside, is going to put the pressure back into that body itself, right? So the pressure exerted by the air is called atmospheric pressure. Now the atmospheric pressure is same in all the direction. First of all, you should remember that the pressure is same in all the direction, where I told you when you pull the piston out, right, it is going to be pulled, but it will go inside. Pull it from the right hand side, the piston will go inside. Pull the piston from the left hand side, it will go again inside. Put the piston from the upper direction, it will again go into its place, and pull the piston from the downward direction, it will go upward. So it is same in all the direction. The atmospheric pressure at the sea level is 1,01,400 newtons per square meter. This is under ordinary condition. So 1,01,400 Newton per square meter is the atmospheric pressure above the sea level, right? At the sea level, sorry. Atmospheric pressure is measured using barometer. There is an instrument or device which you can call named as barometer. So barometer is used to measure atmospheric pressure. And the last point of this is atmospheric pressure decreases as we go above the sea level, higher above the sea level. Now you can see in this picture that at the sea level there is lot of air molecules. That means atmospheric pressure is higher at the sea level. That is 1,01,400 newtons per square meter. And as we go higher above the atmosphere, the atmospheric pressure decreases. Now this is a little fun of your textbook. Like a piece of cardboard on the, you have to take a piece of cardboard. You have to fill the glass up to the rim and put a cardboard, holding the cardboard firmly, just, invert the glass. Now take away your hand, what happens? Take away your hand after that, what happens? The cardboard will not come out and the water will not spill. Right? Why? Because there is atmospheric pressure which is pushing the cardboard upward so that the cardboard doesn't fell. So air pressure exerted on the cardboard from underneath is greater than the weight of the water inside the glass. This is why the cardboard managed to hold up the water, not letting it spill out. This is about the scientist named as Daniel Bernoulli. So he is a Swedish scientist. So he put forward his important principle about the pressure of air. So he says the pressure of air decreases when its velocity increases, while the pressure of air increases when the velocity decreases. Quite understood? Pressure of air decreases, so velocity will increase, and pressure of air increases, then the velocity will decrease. If a body is moving through the air air pressure decreases perpendicular to the direction of the motion, and then the air in the surrounding flows rapidly from higher pressure to lower pressure. So this is all about Daniel's principle. When the velocity of air increases, the air pressure decreases. When the velocity of air decreases, the pressure increases. Now when the body is moving through the air pressure decreases perpendicular at the 90-degree angle to the direction of the motion, and this results in the rapid flow of surrounding air pressure, like from air from a higher air pressure to the lower pressure. Now we have wind. When there is a difference in the air pressure at two different places, the air shows the movement from place of higher pressure to the lower pressure. This is called breeze or a wind. See, we all have learnt about sea breeze and land breeze, right? We all know the condition. So when the air, when the the place has a higher pressure, so higher pressure moves towards the lower pressure, or lower pressure moves to the higher pressure. So because of that, breeze or wind is blowing. This is called breeze or wind blowing. An effect of a difference in the air pressure causes wind. Now you can see here, when the pressure is high, it moves towards the low pressure, and the low pressure goes upward. Now we will discuss about condensation. Condensation is what? The vapor in there is a water vapor in the air. So this water vapor comes in contact with the cooler thing, and it cools down and condenses. Okay, and the vapor is then converted into water. Humidity in the air, that is moisture in the air. You can see here the moisture in the air. So the level of humidity depends upon the following factors. First, place is important, whether it is at the higher altitude, whether it near the sea. Okay, time of the day, what is the temperature, vapor holding capacity, temperature, what is the temperature at present, and what season it is. So humidity depends upon 5 things: place, time of the day, vapor holding capacity, temperature, and season. This is dew. Nice picture, no? Now here, when the temperature of the air is low, that is during the night time or dawn time, its capacity to hold the water is reduced. It's very less. During the night time, it cannot hold water too much. During the dawn time, it cannot hold water too much. In such condition, the excess of water vapor which is there is transformed into small water droplet, which you can see it early in the morning on top of the leaf, right, or on the surface of your windows, right? So you can see these dew drops. So these droplets are dews. Now this is scattering of light. Due to particles in the air, scattering of light takes place. Okay. Now temperature regulation. Earth receives energy from the sun. This energy is reflected by the earth in the form of heat. So this reflection, the heat which the earth receives from the sun, it is reflected, right? And we all feel the heat of the sun. The constant of air surrounding the earth, such as water vapor, carbon dioxide, and other gases, right, absorb a part of this heat and give it to one another. The molecules heat each other. So they are giving that heat to one another. As a result, the earth's surface remains warm and thereby becomes suitable for the living world on this earth. So what happened? There are the other constituents. So when the heat is received by the sun, it gets reflected, and there are so many other gases which are present in the atmosphere. They absorb this heat and they start hitting one another, and they are passing this heat to one another. Therefore, the atmosphere becomes warm. Okay, because the envelope itself is getting warmer, and it becomes suitable for the living being to survive in a warmer kind of place. If there is no air on the earth, the average temperature on the earth's surface would have been very low. So this is how it's reflected. The sun heats the earth, it gets reflected, and this reflected thing is absorbed by the other gases. Transmission of sound. So sound transmission means sending from one place to another. Sound waves are transmitted by particles which are present in the air. Now this is the speaker. From the the waves which are present in the atmosphere, so they carry the sound. You have learnt in 6th standard. So they carry the sound to your eardrums. This is how sound travels. Now transmission of sound depends on the medium. Air is an essential medium for transmission of sound. The density of air changes due to the change in temperature. And the clarity of sound depends upon the density of the air, how heavy or how light is the air. Now we have come to the topic, that is water. Now you have seen water. Water is liquid. Water takes the shape of the container. We all know that. Now, what are the state in which water is found? Water occurs in three states, right? That is liquid as in plain water, solid as in ice, and gaseous as in water vapor. I'm not going to take this. I'm just going to tell you that the experiment which showed, if you take the balloon, okay, take the balloon, fill the balloon with water, okay, the balloon will get bulged out, that because there is water inside. Water has occupied the space. Now, if I pierce the hole, right? If I pierce hole into that balloon, what will happen? All the water will come out and the balloon will deflate, right? Now, there's a container with so many holes in it. I've filled the balloon, I've filled the container. Now the water are coming out. Now from that cylindrical container, the water is coming to the tub. Now that water gets filled up in the tub and it takes the shape of the tub. Now you can see here the water which is filled here in different containers have different shapes, right? So water occupies space. Water does not have its own shape. It takes the shape of the container in which it is filled. Water is fluid in nature, as we know, right? So now what are the properties? Water is fluid substance that is found in liquid state at room temperature and at ordinary condition, right? Water has its volume, but it does not have its own shape. It can seep through a small hole or crack. You can see here. Now water freezes into ice. It expands at its volume and its volume increases. Solid becomes lighter than the original liquid. And hence it floats in water. I will explain you this. Density of water is the interrelationship between the volume and mass of a substance. Volume is the space occupied by the substance. What is volume? Volume is a space occupied by a substance. And what is mass? Mass is a stored substance that is stored in a matter, stored matter in a substance. Density of water. The interrelationship between the volume and the mass of the substance. The space occupied by a substance is its volume. The stored matter in the substance is its mass. Now, density is equal to mass upon volume. We'll write mass is measured in grams and volume in cubic meters. Now, I'll just explain you this. Density is equal to mass upon volume. That means whatever is the mass divided by the volume, right? Hence, density is equal to gram upon cubic centimeter. So, density is equal to gram upon cc. Hence, G upon cc, gram per cubic centimeter is the unit of density. Now, this we'll understand with the help of an example. If the mass of 1 liter of water, in 1 kilogram is 1 kilogram. That's what is the density of water. That is the expression. 1 kilogram means 1000 gram. 1 liter means 1000 cubic centimeter. What will be the density? Density is equal to gram upon cc. So we'll just write 1000 density is equal to 1000 gram, that is kilogram, upon 1000 cc. 1000 will get cancelled. We will be just getting it gram upon cc. So density is equal to 1 gram, 0 cancel. Okay, 1 cc. Therefore, if the water's mass is 1 kilogram, then its density will be 1 gram per cubic centimeter. This is one of the best topics which I love to discuss with my students, like anomalous behavior of water. Anomalous means abnormal behavior of water. Now I'll explain you with this anomalous behavior of water. Here you can see. Now water is like normal, like other normal liquids, right? Now the normal liquids, what it does, when we try to keep in a freezer, the normal liquid actually, when it starts cooling down, its density increases like most of the liquid. So all the liquid, actually the density increases when it is cooled. But in water, what happens? The density increases like most of the liquid. But this happens in a normal temperature. But when its temperature falls down below 4 degree, means after 4 degree, right? After 4 degree, then there will be 3 degree, 2 degree, 1 degree. So it falls down. So its density starts decreasing. The weight actually becomes less. The density becomes less, right? And therefore the density of water is maximum at 4 degrees centigrade. Means when the water level, right, from 26, from room temperature, if you have taken room temperature water, keep it in a freezer, it will become heavier. When it is there, it will be kept in the fridge, it will become heavy. But when the water cools down, like from 26, 22, 20, 20, 20, 18, 19, 18, 17, 16, 15, 10, 9, 8, 7, 6, 5, 4 degree temperature, when it comes to the 4 degree temperature, it will increase. But as soon as it falls below 4 degree, the temperature goes below 4 degree, means 3.9, you can take it, degree Celsius, the density starts decreasing, right? So you can say that the density is maximum at 4 degree Celsius. Now when the temperature of the water is lowered below 4 degrees Celsius, its density decreases but its volume increases. The water, when the water starts decreasing, the density starts decreasing, then volume starts to increase. Now we all have done this experiment in our childhood. Now you are our children. When I was a child, I also did one experiment. I kept a glass, glass made up of glass. So it was not a steel, but it's actually a glass bottle, glass, and I filled the water and kept it in a refrigerator. As I did not mark it, but I kept it in a freezer, and that water started to this water started to cool down. Then it became ice, right? It became ice. When I lifted the glass was cracked. The glass bottle, maybe it will crack. Or if you have done any experiment, such as if you have kept a bottle of water in a freezer, right? When you took out the water, which has become ice, that water, the ice, actually comes to the rim of it or above it, just 0.5 centimeter higher. Why? Because the volume increases. That proves. You can do the experiment if you want. So when the temperature of the water is lowered below 4 degrees centigrade, the density decreases but its volume increases. This is called the anomalous behavior of water, the abnormal behavior, behavior of water. And because of that only, in the countries where there is snow, right, in the Arctic Ocean or something like that, right, why the fishes can survive inside that 0 degree Celsius? Why? because because when the water reaches its maximum at 4 degree, the upper portion you know becomes 0 degree. Then that upper portion, the lower portion, is maintained 4 degree. That's in liquid, this, right? So that is anomalous behavior of water. Water expands when the temperature falls below 4 degree. For all the other substance, when the water is lowered, its density increases as the volume decreases, but does not show this. This is a peculiarity of water. Only this has been done by the water only. Now water dissolves everything, so we are going to study that only, dissolving. The substance that completely dissolves is called soluble substance. Here, dissolving salt causes increased density of water, that I will explain you. Now you have two eggs. One is you have 2 glass of water. You are going to fill the glass of water with the normal drinking water and place 2 eggs inside. So the eggs will go inside the water, it will sink. Okay. Now as just remove 1 egg, put 2-3 spoon of salt in it, dissolve in it, and when you dissolve it and put the egg again, now you will see the egg will not sink, it will float on the water, float in the water. Why? Because the density has increased. Now when the process of dissolution takes place, the particle of the salt spread in the water and slowly becomes smaller and smaller. When you put the sugar or salt in it, stir it, and this what you have, your the salt which you are stirring in the water completely dissolves with the water. So ultimately they disappear. During this process of dissolution, solute mixes with the solvent and what does it form? It forms a solution. So we all know how to make lemonade. This is salt. It is solute. The substance that dissolves, that is salt. Then we have solvent, substance in which the solute dissolves. And the third part is solution. What we get after mixing solute and solvent is known as solution. That is salt water. So now these are the uses of water according to its property. Water is useful for water transfer due to its fluidity. Water falling down from the height, it generates electricity with the help of generator. Now we have to understand why it happens, because of the energies, kinetic energy, potential energy. Okay, that we'll be learning in the further classes. Now water is a good coolant and is used in a motor vehicle to control the temperature of the engine. Many substances are soluble in water. Water is a universal solvent. As we know, most of the substances get dissolved in water. Water is used as a solvent in factories, laboratories, foodstuff, and in various type of biological process occurring in the body, such as digestion, excretion, etc. Now, water is useful for cleaning purpose, such as bathing, washing clothes, utensils, many more things. For cleanliness, right? These are the things. Now there is a another natural resource, that is soil. What is meant by a soil? How is soil formed? So soil makes land. We all know we stay on the land, we live on the land. The process of the formation takes place at a very low pace, at a very slow pace. Now it is a natural process in which heat, cold, and rainwater causes weathering of the bedrock. The weathering forms stone and smaller particles of soil, etc. from the original rock. Microbes, worms, insect, and rodent also act as a weathering agent. In this way, soil is continuously and slowly formed. Now you can see other picture, soil formation. These are the ingredients which are found in a soil. As I told you, ingredients. Now these are the worms and all, insect and all. Soil contains abiotic constituents such as smaller particles, sand, rock, stones, etc. And there are some biotic components like worm, insect, rodents, and microbes are all biotic constituents. See, abiotic components are non-living components. Abiotic component constituents means non-living constituents, and biotic constituents means living constituents. Now, this experiment shows there's a nice video also regarding this experiment. There are three types of soil here. One is clay, one is loamy and sandy soil, and one is completely sand. Okay, sandy soil is mixture of clay soil and the what you call the mixture of sand. So, the clay soil is actually containing too when I pour the water, when I will pour the water to the clay soil, what will happen? It will absorb more of the the water. It will become more soggy. When I pour the water into the sandy soil, what will happen? It will retain some water and let the water, it will flow off all the water. But the sand, the entire water will just go out of the water. It cannot hold water. The water holding capacity is very less in sand. And when there is a mixture of sand as well as the clay, they hold the water, but they don't let the water sit there. So now the property of soil. First, you need to know the color. The soil gets its color as a resultant of several processes. The color of the particular land is dependent upon the soil color. Now, color of the soil is like black, red, copper, yellow, gray. Now, classification of land is done from the color of the soil. Properties of soil are dependent on the color of the soil present there. Okay. Now, properties of the soil such as its fertility, how much fertile is the land, drainage of water, capacity to hold the water, depends on its color. Now, the color of the soil is dependent upon its texture. What kind of a texture it is? Is it thick, very fine, or clay? Organic ingredients, how like humus is present or no? Whether the dead decaying things are there or no? So it comes under humus only. And chemical ingredients like how much is the iron, how much is the lime in it. Okay. Now these are the texture. I'll just go through the texture here. Soil texture. The texture depends upon the proportion of the particle of the various sizes in it. So according to the texture, you can identify the soil. So this is sandy soil, all made up of sand. This is silt soil, mixture of clay and mixture of sand. And one is clay soil. The proportion of the sandy soil, the proportion of the large particles of sand is more. Through such soil, water drains rapidly, plowing is easy, soil is less fertile, particles are made up of silicon dioxide, which is also known as quartz. These particles are insoluble in water, therefore the soil supplies less nutrients. Now this is silt soil. The particles are of medium sizes. Silt soil is not easily plowable, contains a large proportion of organic material, good capacity to supply nutrient, and also called as sedimentary soil. Clay soil, as you can see, it is too sticky. The proportion of smaller particle is maximum, difficult to plow the soil, and the particle of the clay soil are smooth to touch, has a high water holding capacity. Now the structure and importance of the soil structure. Now structure of the soil occurs in the form of columnar, laminar, granular, as well as in a block shaped structure. This structure depends upon the different shape of particles in it. Now the fertility of the soil also depend upon the structure. The advantage of the good soil structure is roots are supplied with good amount of oxygen, good water drainage, and good growth of plant's root. Yeah, this is the soil structure, columnar, right, granular. Now uses of soil you can use for plant conservation to help the plant grow, water conservation. Soil holds water as the result by the means of bunds and lake we can get water for use throughout the year. And plasticity, that soil can be given any shape. So whatever shape you want you can give to the soil. And some useful type of soil are china clay, that is kaolin, is used. It is white in color. It is used to make crockery, bathroom tiles, tank, laboratory apparatus, masks, jars, etc. Sadu soil, it is whitish in color. It is used for making statues and idols. Now this is terracotta soil. This soil is red in color. Decorative articles and pots used for growing plants are made from this soil. And one is multani soil. This soil is used in cosmetics. So soil testing. Soil testing is done to find out the proportion of various ingredients of soil and to decide the fertility of the soil. So during soil testing, different parameters are checked. First is color, texture, and proportion of organic matter. If there is some deficiency of ingredients and to decide measures to cure the soil testing by reducing the deficiency. The soil sample collected for the testing is dried up in an open air in a shade for 8 to 10 days, and then later it is shifted through the sieve. Then there is a pH meter with the pH and the electrical conductivity test are important to determine the soil characteristics. Now, what causes diminished the soil fertility? Soil's pH, if it is less than 6 or higher than 8. Low proportion of organic matter, if there is no proper drainage for water, if you are continuously using salty water or saline water, repeated cultivation of the same crop, you are growing the same crop again and again, the soil fertility gets deteriorated. Excessive use of chemical fertilizer, if you are using too much of chemical fertilizer and pesticide, then also the soil fertility gets damaged. So this is always remember, soil texture is disturbed if chemical fertilizers are used excessively and that land becomes unsuitable for sowing. Crops should be rotated in order to maintain the fertility of the land. Now, for example, the fertility of the land decreases after a harvesting of wheat. So, you don't have to harvest the wheat again. So, hence, after the harvesting of wheat, leguminous crop like peanut, moong, moat, beans, pea, lentil, Bengal gram, soybean should be cultivated to restore the fertility of the soil. Because leguminous plants, there are some organisms which are present which helps in fixation of nitrogen, which is very good for the land as well as plant. So they help in bringing or restoring the fertility of the soil. So this is about the great scientist, that is Danish scientist Sorensen put forth the concept of pH based on the concentration of hydrogen ion to determine the pH of the soil. A mixture of water and soil in the proportion of 1:2 is taken and tested using several indicators. There are pH indicators. So accordingly, soil may be found to be one of the following three types. Where it can be acidic soil if the pH is less than 6.5. There can be a neutral soil if the pH is between 6.5 to 7.5, and alkaline soil pH is higher than 7.5. Now, to make efforts for conservation of soil, every year on 5th December, World Soil Day is observed so that people become aware. So, I hope you have understood the chapter very well, and if you have really liked the way I have explained to you all, you can write it in the comment box. And if you want any of the chapter, this was from the state board's 7th standard. So if you all want any chapter from your board also, I will make a video on it, and just comment me uh, in a comment box saying which chapter you want, how you want. If my pace is very very fast, so I should go slow, whatever is your comment, feel free to comment on the comment box. Thank you so much.